So today we're going to look at finding a constant rate of change. So remember, what does the word constant mean in math? The same. So the same rate of change. And think about rates. Rates like unit rates, miles per hour, dollars per pound. So it's a rate that is changing the same every single time. So maybe it's always going up by 4, always going up by 6. And so that's what a constant rate of change is. So a rate of change, that shows how fast or how slow something is changing. And usually we express these rates of change as unit rates. So you all are very familiar with that. So a constant rate of change, a rate of change that is always the same. And one important thing to remember is linear relationships have a constant rate of change. Linear relationships have a constant rate of change. Okay, so remember yesterday, a linear relationship, what does that make when you graph it? What does a linear relationship make when you graph it? A straight line. Okay, so linear means straight line. So what other type of relationship makes a straight line when you graph it? That we've been talking about for the past 3 weeks. Proportional relationship. So linear relationships have a constant rate of change. So do proportional relationships. And remember, what was one of the criterias for being proportional? Constant ratios or constant rates. That's the same thing, because a rate is a ratio. And so notice how everything's kind of coming together in this lesson. So if you're looking at a straight line, think about if you're going from one point to the next. You're always going to go up by the same amount. Every time you go from this point to that point, from this point to that point, from this point to that point, it's always going to be the same amount. You might have to simplify, but if you simplify all of those rates, you're always going to get the same thing. So a straight line is always growing by the same amount. That's the constant rate of change there. And going from one point to the next, that's one thing that we're going to talk about next week as well, looking at different lines. So when we are trying to find a constant rate of change, we're going to be given this information in a table or a graph. If we're given the information with a table, we're going to find the amount of change for both sides. So there's two sides of the table. We find the amount of change and then we're going to write that as a unit rate. Write that as a unit rate. And the unit rate for both of these is always going to be y over x. So the unit rate is going to be y over x. If we're trying to find the constant rate of change with a graph, we're going to find two ordered pairs, 2 points on the graph. Don't make one of them 0, 0. So 2 ordered pairs on the graph. And then we're going to write those as a unit rate as well, as y over x. Y over x. And we'll notice that when we write those unit rates and simplify them, we always get the same thing. So a big thing to remember, the unit rate, like we talked about yesterday, figuring out what is y and what is x. Remember, x is the one that we can change. X is the independent variable, like hours or amount, like pounds or something like that. So we'll write it as like hours over money or whatever it's going to be. Okay, so our first example here, we have a table that shows the amount of money and the number of cars. So we've got to find the constant rate of change. So the first thing that I want to do is figure out what is x and what is y. So which one would be x? Which one can we change? The number, yeah. We can change the number. So write x above number, y above money. And remember that we are going to write this as y over x. As y over x. Okay, next thing to think about is this is the constant rate of change. So we want to figure out what is it changing by from one line to the next. Well, for the number, what is it always changing by? It's always going up by 5. So we'll say positive 5. The money is always changing by 40. So we'll say that's positive 40. Once we figure out what it's changing by every single time from one row to the next, we're going to write 40 over 5. Y over x. 40 over 5. And then what do you think the last thing we need to do is? Simplify it. Yep. 40 divided by 5 would give us 8, or 8 over 1. And then attach the units with it because it's a rate. This was $8 for every one car. So $8 for every car. So that's that constant rate. We find what is it changing by from one to the next. Write that, and then we're going to write that rate as y over x and simplify it. So similar to what we did yesterday, we also did this earlier before fall break talking about unit rates. We did that a lot with a table like this. Okay? So I want you all to go ahead and do the next one. Figure out what x and y are, find the change, write it as y over x, and simplify it. Okay, so in this example, which one is going to be x? Which one is the independent variable? Taylor? Buses is independent, good, yep. And number of students is going to be y. So it's going to be students over buses. So how much is students changing from one to the next? Plus 72. And then number of buses is going up by 1. So this one's going to be easy because, to simplify it, it would just be 72 students per bus, or every one bus. Good. And that's that constant rate of change, is going up by 72 every time. All right, any questions on looking at a table and doing it that way? Okay, so let's look at reading a graph and doing the same thing. So we're going to look at this graph and say, okay, what's the constant rate of change? So one thing that I want you to notice, you can probably see it easier on your paper. If I'm going from one point to the next, and they have the points written out there for you, I'm always going up by the same amount, and I'm going to the right by the same amount as well. Right? I'm going up by 3, I'm going right by 2. Up by 3, right by 2. And so that's the constant part. It's always the same that you're changing from one point to the next. We're still going to do the same thing. We're going to write it as y over x. So on this graph, what is y? Look at the y-axis. Distance, which they say it's miles. So I'm going to put miles. And what is x? Fiona? Time, and they say that is hours. So miles per hour. Okay, and then what I'm going to do is just choose one of those points that they give us. It does not matter which one I choose. Just don't choose 0, 0. Doesn't make much sense to do that one. So I can choose 61, 122, 183. How about we choose 60 or 160? 160. So remember, it's y over x. Y over x. So 60 miles every 1 hour. And that is already as a unit rate, so I don't have to simplify. But just to show you, if I had chosen 2 120, what would that have simplified to? What's 120 divided by 2? 180 divided by 3? 60. So it's always going to get you 60 over 1. That's one great thing about it being a straight line. You simplify that, it's always going to be the same thing. Now they also ask us to explain what the points 0, 0, and 160 represent. So 0, 0, well, that's going to represent the start. Yeah, usually we say 0, 0 is the start. So 0, 0 is the start. Because in 0 hours, you've traveled 0 miles. And then 160. Think about the different things that a proportional relationship has. What's the one thing that we've talked about that has to do with the number 1? It's always over 1. You divide to get 1 at the bottom. What is that? The unit rate. And so 160 in 1 hour, that is the unit rate. So the constant rate of change is 60 miles per hour. 0, 0 is the starting point. And 160, that point, is the unit rate. Okay, one important thing that I want you all to write down, maybe at the top of this, if you have room up there, because this is extremely important. When x is 1, that point is the unit rate. So if you are looking at a graph of a proportional relationship, if you're looking at the graph of a proportional relationship like this one, it's a straight line that goes through the origin. the point where x is 1, that is the unit rate. You're going to be asked that question quite a bit this year. What does this point, 1, comma, whatever, what does that represent? It's always going to be, it represents the unit rate. Because in 1 hour, gone 60 miles. So when x is 1, that point is always the unit rate.
Is that on the table?
No, but sometimes they're going to say find the unit rate, so they won't give you one all the time. Any other questions? All right, so go ahead and answer the next one. Make sure you answer all the things that they ask you about. So remember, when we find the constant rate of change, we want to do mile or y over x, which would be miles over hours. And so what is that constant rate of change going to be? I'm plugging in 2 points. 30 miles in 1 hour. Good. 30 miles over 1 hour. And if you would use 60 and 2 and 90 and 3, you would have still gotten 30 over 1. So make sure you write that as the unit rate. Okay, the point 0, 0, once again, that represents the starting point. It's not always going to be the start, but in this case we're talking about what are you doing if you've got miles per hour? Like driving, right? So you're driving, that's going to be the starting point of whatever this is, the trip or whatever. So 0, 0 is the start point. And then we say that 130 is the what? Is the unit rate. Now, if you were talking about maybe dollars and pounds, 0, 0 wouldn't be the start point. It would mean if you don't buy anything, you don't have to pay anything. That would be what 0, 0 represents. So make sure your answer matches what is given on the x and y axis. Okay, any questions on reading the graph to find the constant rate of change? All right, one last question that we'll look at is using a table and a graph. So the table and the graph both show the same thing. You're talking about cost and number of hours. Okay, cost and number of hours. The question is, which store charges more money per bicycle? Store 1 in the table or store 2 that's given in the graph? So these are information from 2 different stores. So what you need to do is find the constant rate of change. That's what we've got to do. So we're going to do y over x for both of them. And notice that y is going to be what? Money or hours?
Money.
Money or cost, yeah, because money is on the y-axis. So y is money, x is hours. The one for the table is going to be 24 over 2. and that's going to simplify to get us how much? 12 over 1. It's going up by 12 every time. So $12 per hour. Okay, and then what about for the graph? What y value would we want to plug in here? So you're going to have to look at the points and see what coordinates they are. What y value would we want to plug in? 8, okay, and when y is 8, what is x? It's 1. Yeah, it's kind of hard to see because they're so close together, but notice it's not 8 and 2. You need to go to the x-axis and see that it's 8 and 1. And so the graph would be $8 in 1 hour. And just to check to make sure we did that right, if you go up to 16, it's 16 and 2. And 16 divided by 2 would be 8. And so the question is, which store charges more money per bicycle? That would be the store with the table. So you want to maybe circle the table. That's the one that charges more money. So y over x is always going to be the unit rate. Find how much it's changing, or find an ordered pair on the graph. Plug that in, simplify. Make sure it's always a unit rate. Whenever we simplify, we want 1 as the denominator. Okay, so we've got a few questions to be working on dealing with constant rate of change.